1. Let's move on here. We were on example 3 here, so let's finish up and see what we have if this ever gets moving. Of course, it's going to sit here and take forever. Okay, guidelines for solving equations with rational expressions. So what you need to do when you're trying to solve these rational expressions is you need to determine the LCD of the rational. That's basically what I'm trying to tell you is find a common denominator. Okay, that's what we want to do with these problems. And then find values that make the denominator 0. So basically, what can we do to make the denominator 0? And you need to look at those and see if they can still actually work. And you want to multiply each term by those common denominators because you want to make them all be the same. And it's basically just like any other regular old fraction trying to find common denominators, what you're going to do, except now we're doing this with variables as well. And then you solve the equation and make sure you check your answer.
Grandpa.
So when we're doing this, this is what I see. I see a problem just like this, nice and spread out, but none of the bottoms have a common denominator, right? So once they all have a common denominator, I can just push the tops together and solve. That's all I basically need to do. So first step is, I like to do is see if you can factor the bottom whatsoever. Okay? This bottom, when I take a look at it, I can factor this. I can take a 2 out of it. So I take a 2 out of that. This is what I actually have. I have a 2 times x minus 2, an x plus 3, and an x minus 2 in the bottom. The reason why that helps is I notice that this one has an x minus 2 in it, this one does not, and this one has an x minus 2 in it. Which means, what is this one missing? It's missing an x minus 2. I notice that this has a 2 in it, this does not, so I'm going to have to also multiply this one by 2 and this one by 2. This one has an x plus 3 in the bottom, but these two do not, which means I'm going to multiply this one by an x plus 3 and this one by an x plus 3. This is how I make everything on the same, or everything on the bottom the same. So because this has an x plus 3 and I'm multiplying the top and the bottom of this one by an x plus 3, and this one needs a 2, and it needs an x minus 2, so that's why I'm multiplying it by a 2 and an x minus 2. But remember, whatever you do to the bottom, you have to do to the top. And this one's missing that 2, and it's missing an x plus 3. So that's why I'm multiplying it by the 2 and the x plus 3. So I end up with a 3 times x plus 3, a 5 times a 2 times an x minus 2, and a 2 times a 2 times an x plus 3. Alright. And all the bases are now going to be the same. They all have a 2 in them, they all have an x minus 2, and they all have an x plus 3. So what I'm going to need to do is just look at the top. That's all that my concern is, because the bottom is the same in all of them. So if the bottom's going to be the same in all of them, then it doesn't matter what the bottom is. All I need to worry myself with is the top. So, alright, so there's the top. So I'm going to FOIL this through on the top. So 3 times x is 3x. 3 times 3 is 9. 5 times 2, that's basically going to be a 10, but it's negative, so it's a negative 10x. And 5 times 2, that's a negative 10, so negative 10 times a negative 2, right? That's a positive 20. That equals 2 times 2, that's 4. So 4 times x is 4x. And 2 times 2 is 4. 4 times 3 is a positive 12. Okay, so let's combine like terms now on this side. I have a 3x and a negative 10x, so I have negative 7x's. I have a 9 and a 20, so that is a positive 29. And I still have the 4x plus 12 left over on that side. So I need to combine all of my x's on one side. So like I said, I like having positive x's, so since this one's negative, I'm going to add, because it's the opposite, I'm going to add 7x's to this side. Those cancel out. So I still have a 29 left over on that side. 4 plus 7 is 11x's. And I still have a positive 12. Because that's a positive 12, now I'm going to subtract a 12, because remember, I moved my x's to the right, so now I need to move my numbers to the left. So 29 minus 12, that is 17. So I have 17, and I still have 11x left over on this side. Since it's 11 times x, I'm going to divide both sides by that 11, and I end up with 17 over 11. Now, you got to make sure you check your answer, and this is where the bottom comes into play. You have to plug this answer in on the bottom to see if it works for all those factors. If this works on the bottom, because remember, you can't have a 0 in the denominator. If this works when you plug it in on the bottom, then this is the right answer. Okay? But in some circumstances, there is no solution, because if you find an answer, it might not work on the bottom. So do not forget to check your work. Plug this in on the bottom and see if you get 0 in the denominator. If you do, this is actually not the answer. Okay? So you have to see if it works in the denominator. And I'm just letting you know to speed up some time, this does work. So since this does work, we are okay for this problem. Example 5, we want to solve for R1. And here's the formula. So this is what we have. R1, R2, and R. These are all different variables. Since they're all different variables on the bottom, I need to somehow make them all be the same before I can combine them together. I need to solve for R1, which means I want to get this all by itself. So to get R1 all by itself, here's what I'm going to do. I'm going to move this. So since it's a positive 1 over R2, then I'm going to minus 1 over R2 to both sides. So now this cancels out, leave me with 1 over R1 equals 1 over R minus 1 over R2. I'm trying to solve for R1, which means I need to get R1 all by itself. So in order to get R1 by itself, I'm actually going to multiply both sides by an R1, because right now it's a fraction and R1 is in the denominator, so I need to somehow get it out of the denominator. So I'm going to multiply both sides by R1, leaving me with them after they cross out with this. Now I know what you're thinking. How does this help you out at all? Because you're right, it really doesn't. But it's all of this junk times R1. So since it's all this junk times R1, and I want to get R1 by itself, I'm going to divide this side, and I'm going to get rid of all this junk, because this will help me get R1 by itself, and R1 is going to end up being in the numerator now, which is where I want my final answer to be. So those cross out. I now have R1 all by itself, but I have a weird fraction. So I'm going to have to find a common denominator for that bottom. Because if you remember the last problem, let me go back here quick. I'm going to have 1 over all this stuff right here. So I'm going to just be concerned with the bottom right now. So that's all I'm looking at, is to find a common denominator for the bottom. So this is my bottom. So this side's R, this side's R2. So I'm going to multiply this side by R2 on both the top and the bottom. I'm going to multiply this side by an R on both the top and the bottom. So when I do that, I end up having an R2 on the top and an R on the top of this one, and I have an R times R2 on the base. Since the base is the same in both of these, I can just subtract the top. So R2 minus R is the top over R times R2. Because I found common denominator, so I can just subtract the tops. So now, you got to keep in mind that's the denominator. So this is actually what I'm looking at right now. Because this was the original, and now I found common denominators for the bottom to give me this on the bottom, and that equals R1. So 1 over this is like me saying I can do the reciprocal of the bottom to find the answer. So all you basically need to do is flip it, and there is your answer solved for R1. So when we come back here, I will try to finish up here some of the rest of our examples in section 1.1 on solving some basic equations in trig.